Very good evening, students. Today, I am going ahead with the topic structure programming that I already discussed with you in last two lectures. I have discussed the introductory part of the structure programming. In my last lecture, I also discussed the array of structures, nested structure, and I have already used the function in structure programming. And I mentioned in my last lecture that we can use the function in structured programming in different ways. Like we can pass our entire structure to a function. We can pass a particular structure element as an argument to a function. We can pass an entire array of structure as an argument to a function. And like this three, a function also can return a structure variable, just like returning an integer, returning a float, returning a char. In my last lecture, I also shown you the examples of these three implementations: passing entire structure to the function, passing a particular structure element as an argument to the function, and passing entire array as a structure argument to the as an argument of a function. We can pass an entire array. That much we have discussed in my last lecture. Today, I start my discussion with the topic that is a function returning a structure. Earlier, we have seen that function return type is, what the function's return type? Function return type is the data type of the return value. Data type of the return value is called the return type of the function. So trying to write a program regarding this, let me share the programming screen with you. I hope the screen is visible to you. So let me consider a structure, struct EMP, which has only two members I consider. One is employee ID, another one is salary of the employee. You may take the name also. So in that case, I have to pick character array, say 20. And I am declaring a structure array along with this. So say member 20. It's an array of structure. That means each and every index, there is an employee detail. In my last lecture, I also used a function to display the array details. The name of the function was display probably. And this function, what this function takes, two arguments. First one is the array, say this is The array type is struct emp, and second one is the, what the second one is the number of employee. Fine. Today I am going to introduce a function which will return a structure variable. So definitely the return type of the function, the return type of this function will be struct emp. And I'm trying to write this function to calculate the maximum salaried employee, rather to find the maximum salaried employee from this given array. Definitely we have to pass these two members. First one is the entire array. Keep it in mind, is because I declared this array as global, so I may omit the first parameter right now. In the earlier example, in the last example that I discussed in the last class, the array is declared locally, so that's why I need to pass array to the function. And because in this program I declared this array of structure, that is name of this array of structure is ARR, which I declared globally. So that's why it is very much known to all the functions along with main. So that's why no need to pass it to the display function or in or in maxcell function explicitly, because it is known to all these functions. I hope you understood this much. What is the purpose of this maxcell function? I'm going to write this maxcell function to what? To do what? To find the maximum salaried employee from this set of array elements. And this function returns a structure variable of type emp. What this function will return? This function will return a particular array index. Right now, when this function returns a particular array index, rather array element, what is the type of this array element? It's a struct emp. It's a struct emp. So that's why I'm mentioning the return type of this function. I'm declaring the return type of this function as struct emp. I hope you understood this much. The next part is int n. I'm taking where n is the number of elements that I have to pass as a parameter of this function. So I'm taking input this n from user, enter the number of employee, scanf %d, comma ampersand n. For this n employee, I have to take input from user. So iterating a loop for I equal to 0 to I less than n, I plus plus. So first I am taking input for the ID, which is integer, then sal, also integer. So printf /n, enter ID. Right? Then scanf %d, comma, ampersand. The name of the array is ARRI. Next, I'm taking input salary. So enter salary. Fine. Scanf ARRI.id. ARRI.salary. And finally, I have to take the input name of the employee, name, and I have to use the getAS function over here. So use getAS function, that is ARRI dot name. So this is the code for taking input, taking employee details from user, or taking input of the employee details from user. Next, what to do? I have to call the display function. This display function, I have to pass only the number of employee, that is n, because array is declared global over here, ARR. And next, what I will do, I will call the maxSal function, where also I take only one parameter, that is number of employee only. And this maxSal function will return us a structure of type employee. That's why I need to declare V. The type of data type of V will be definitely struct TMP. And after returning V, that means after returning that employee, I need to print the details of V. That is, that part I am writing later. First, write to define display function. So void display is the function name. Int x, n will be copied over here. So int I, for I equal to 0 to I less than x, I plus plus, then I will print the details of the employee. Printf, first one is ID, /n ID equal to ARR I dot ID. Fine. Then what next? Printf /n salary equal to ARR of I dot salary. Fine. And finally, the name of the employee that I will print over here. How to print? Printf /n name equal to %s ID equal to %d. Forgot to write, very sorry. Sal equal to %d, name equal to %s, comma, ARR of I dot name. So this is the details of this display function. And I have to print the same after calling the function maxSal. maxSal will return a particular employee as a form of structure variable, and that is stored inside V. So I am printing the maximum salaried employee details by writing v.id, v.salary, and v.name. This is the details of max sal, maximum salaried employee. I hope you understood this much. The calling of, rather the definition of display function, already discussed in the last lecture. Now I am trying to define the function max sal, which is basically used to define, rather used to return a structure variable, a variable definitely type struct emp, and which variable? The employee, who has maximum salary among this all employee elements which are exist in this current array ARR. So finding maximum from an array, we all know the logic. We consider the first element as the maximum element. So that's why ARR 0.salary is considered as max. Fine. Then I is the counter variable and j is the index of maximum salaried employee. Initially, I considered it as 0 as because I consider at the 0th index we have the maximum salaried employee. So I start my comparison from index 1. If ARR of I dot sal is greater than max, then definitely I will update the max. Max will be ARR I dot sal, and at the same time I must update the value of j also, because j is basically storing the index of maximum salaried employee. So finally, after coming out from the loop, I'll return ARR of j, and that value will be stored inside v, and after returning the value, I will print the details of v. We have only 3 members, that is ID, salary, and name. I hope the detail of maximum salaried employee will be printed by using this code. So let me execute the program. So enter the number of employees. I am considering it is 5. ID 1, salary 12,000, name is skipping. So let me give a F flash before get s. So as because the problem I facing in my last lecture, I discussed why I have to write this F flash std in. The buffer becomes full. That's why the input is not scanned by this getS function. Fine. Again, I am compiling and executing the program, considering number of employee 5, ID 1, salary say 12,000, name A. Second employee ID 2, salary 15,000. Fine. name I consider B. Third employee 3, salary 17,000 and name I considered C. Fourth employee ID 4, salary 9,000, name I considered D. ID 5, salary 8,000, name I consider E. So the maximum salaried employee is in ID 3. Fine. So this is the first part of the output, is basically the output of the display function ID 1, 2, 3, 4, 5. Now the details of max salaried employees. ID equal to 3, salary 17,000, name equal to C. So I hope this program is clear to you. This program basically demonstrate the concept of a function which returns what? And not an array, which returns a structure element. As because it is returning a structure variable or returning a structure element or returning a structure, better to say. So that's why the return type of this function is the data type of the structure. What is the data type of this structure I consider? It is struct TMP. So that's why the return type of this function that I consider over here is struct TMP. Fine. Next part, I am going to discuss, that is, I try to introduce pointer in this structure concept. Fine. So what do we know so far about pointer? What is the basic definition of a pointer? We know that pointer is a variable which can store the address of another variable. That much we know. Fine. I'm modifying this program, so that's why first I have saved it in some other name. Then I will modify it. I will not take an array over here. So thing is that pointer is a variable which can store the address of another variable. And we know about the indirection operator. We know about the ampersand operator, that is address of operator. So we already aware about these two operators. Today I'm going to discuss this pointer concept with the topic structure. So pointer is a variable which can store the address of another variable. Earlier we have seen that a pointer variable can store the address of another integer variable, another float variable, another character variable. So just like that, a pointer variable can store also the address of another structure variable. That is the point that I want to highlight right now. The pointer, we can declare a pointer variable in such a manner that pointer variable can store the address of another structure variable. So how to declare a structure variable, that we already discussed earlier. Say E1 is an employee of type this struct TMP. So I'm removing this display function, better to say. Before removing it, just take it copy, make it copy. I'm pasting over here because I'm not taking any array for time being. I'm just taking only one structure variable, that is E1, and this for this E1 I am taking the value of these three members of this E1. Fine. I'm removing this code, removing the display part and as well as max salary part from here. So E1 is the structure variable that I declared over here. Number of employees not required so far. Fine. This line I'm not required. Any loop is also not required. So I'm scanning the ID of this E1. So that will be E1.id. Fine. E1.id. E1 dot ampersand E1 dot salary. Very nice. And E1 dot name. That is the scanning part of this employee E1. Taking input for employee E1. And then I am displaying the details of E1. E1.id, E1.salary, and E1.name. It's very simple program. Just like the first program of the structure, return 0 or 1. Fine. So let me check whether it is running fine or not. So only one employee I'm taking. ID 1, salary 12,000, and name of the employee is A. It is coming in the output. Taking input for that employee and printing the details of the employee. I'm doing this task over here. So now I will do this task using pointer. That is my objective. So that's why I've written this very simple program. So far we have declared a pointer variable, just like int star ptr, float star ptr, cat star ptr. So here I will declare a pointer struct tmp star ptr. What is the meaning of this? Let me tell it first. What is the meaning of this? The meaning of this is ptr is a pointer variable. PTR is a pointer variable. Once again, I'm repeating. PTR is a pointer variable which is used to store the address of another variable of type struct emp. Once again, I'm repeating regarding this declaration PTR. PTR is a pointer variable. PTR is a pointer variable which PTR is a pointer variable which is used to store the address of another variable of type struct emp. I hope this much is clear to you. So definitely when I'm declaring PTR star PTR, so I must have to assign some variable to this PTR. I must have to assign some variable to the PTR. So that I will do by writing this code in this manner. PTR equal to ampersand E1. Fine. PTR equal to ampersand E1. It's very simple. PTR equal to ampersand E1. That means PTR is storing the address of which variable? Variable E1. Fine. Now, definitely, your next question will be how PTR will access this structure member. How PTR will access this structure member? Will it similar to that dot operator? Will it be similar to that dot operator? Answer is no. Answer is no. It will not access, it will not use, where to say, dot operator to access this members. So then how it will access those data, those members of structure variable? It use an array, it use an arrow, not array. It use an arrow, but there is no key, just like arrow. So it is use a dash and greater than sign. So to access the data member through PTR, instead of E1, what I will write? What I will write? In case of normal pointer variable, we will write star PTR to get the value. Right now, we'll write star PTR to get the value. But when the pointer used in a structure variable, we have to write PTR, because the name of the pointer is PTR, and instead of dot we have to write this arrow. Fine. So PTR ID, PTR arrow ID, PTR arrow salary. Fine. And this PTR arrow name. Try to understand. Normally, in case of pointer variable, earlier when we use this, we will use that star operator. The name of the star operator is dereferencing operator to get the value. But here, when the pointer is used with respect to structure to access the data members, we will not use the dot operator. We will use arrow to access the data members through this pointer variable. Fine. So let me run the program. ID 1, salary 12,000, and name is A. Look, the output comes. So then my next question is, so if I use the dereference operator over here, to access these data members. Can I use those dereference operator over here? Yes, we can use the dereference operator over here. Just like this way. I'm writing this once again. So when I use dereference operator, then we can use this dot. But that dereference operator that I will use, I must have to write inside this parenthesis. Why we have to write this inside parenthesis? I'm explaining that matter. So that should be, the code will be look like this. Star PTR dot ID star PTR dot cell and this star PTR dot name. So when we use dereference operator to get the value, then we can use that dot operator to access those members. But we must have to write this dereference operator inside parenthesis that is equivalent to PTR arrow ID star PTR within bracket dot ID is equivalent to PTR arrow ID. Star PTR dot cell is equivalent to PTR dot cell, PTR arrow cell. Star PTR dot name is equivalent to PTR arrow name. Fine. Here we use the dereference operator. Next question, why this parenthesis are needed? Because the structure member operator, that is the dot operator, has the higher precedence than the dereference operator, that's asterisk or star. Dot operator has the higher precedence than the star operator. That's why if we not give a bracket within, if I not write this star PTR within bracket, within parenthesis, so first it evaluates, it going to evaluate the value of PTR.id, which interprets nothing, because PTR is a pointer, .id cannot interpret any value. So that's why first we have to get the value of that structure variable, that is E1. So star PTR means actually it is basically storing the address of that structure variable. So I'm getting that structure variable first. Then that structure variable is very much eligible to use dot operator on the member. Fine. So let me check the output of this program. ID 1, salary 12,000, name is A. Look, it is coming. So we can use the the point I want to discuss over here. The pointer variable, when the pointer variable is used to access the member variable of the structure, I will use arrow instead of dot. When I am writing arrow, it can directly access the data member. If I want to use dereference operator over here, we can use it. And when we can we use the dereference operator, that is asterisk or star, that must be written inside parenthesis. Why that must be written inside parenthesis? Because the precedence of this dot is greater than this star. So if I not write it inside this parenthesis, so it will evaluate this dot operator first, which interprets nothing. ptr dot id, ptr cannot access id through dot operator. Just I mentioned earlier, ptr, if ptr is access the member id, trying to access the member id, that should be accessed by using arrow, not dot. So that's why this star ptr must be written inside parenthesis. Next part of the discussion is, can this pointer variable be used to scan a data member? That just like the member ID, salary, name. Can I use this ptr to scan these data members? Just like in earlier programs, when we use the basic pointer concepts, we use the pointer variable to scan the value from user, or rather for the purpose of taking input. So my question is same over here. Can this pointer be used to read the values of structure members from the terminal or from the user? The answer is yes, we can use it. We can use it. Next question is how we can use it. One approach is, we can, instead of this E1 arrow ID, we have to write ptr arrow ID. This is one approach. ptr arrow ID. Not only ptr arrow ID, sorry, it is ampersand ptr arrow ID. Similarly, when I'm taking salary, it should be ptr, sorry, not E1. It should be ptr ampersand ptr arrow sal. Fine. And for the taking input of a string, is because we did not to give any ampersand, only array name is enough to pass it. So in that case, I only write ptr arrow name, no need to give ampersand. So let me execute the program. ID 1, salary 12,000, name A. So it is coming, fine. So we came to know how this point variable can be used to scan data members, to scan the value of data members of a structure variable. So I hope this much is clear. This is the basic pointer concept which can be used in a structure, and using this pointer variable, We can pass the pointer variable also to a function. In that case, the structure is passed to the function as a reference, not as a value. So try to pass it as a reference. Just I'm writing a function, say void display once again. This function is used to which purpose? The purpose of this function is to display the details of a particular employee. But I want to pass this employee structure variable not as a value, as a reference. So definitely I have to pass a pointer variable over here, and the data type of this pointer variable should be struct tmp star. That's because it's a pointer variable, so struct tmp star. So going to define void struct tmp, void struct void display void display struct tmp star ptr, just like normal call by reference concept. Fine. So in this part, I will print the employee details, the code that for the display purpose, I will transfer it inside this function. So I will not pass any, rather I will not declare any pointer over here. Fine, I will omit this to line. I'm omitting this to line. Display function will be called over here. So there is no pointer variable. Employee E1 is there, fine. So I'm taking input from the user by using dot operator, E1.id, E1.salary, ampersand E1.id, ampersand E1.salary, fine, and E1.name, fine. Next, what I'm doing, I'm calling this display function, and I'm passing this address of E1 as a parameter. That will replace PTR. So PTR equal to address of E1. And the details of employee 1 or E1 will be printed as the output of this program. So let me check the output of this program. Employee ID 1, salary 12,000, name A. Look, through display function, I'm printing the details of employee E1. I have passed the employee not as a value, as a reference I have passed that I want to highlight through this example. So I hope this much is clear to you. So what we learned so far from today's lecture, so far we learned a function which is returning a structure. Second example, we introduced the basic pointer concept in a structure, and that structure pointer is used to, how this structure pointer can use to print the member of the structure variable. that is ID, salary, name over here. How the pointer variable can be used to take input of those members from user, and also discussed about how a structure variable can be passed as a parameter, not as a value, as a pointer, or rather as the address of that structure variable as a parameter to a function. That is concept of call by reference I have introduced in structured programming. So I hope this much is clear. Next point, or rather the last topic of today's lecture that I'm going to discuss, that is dynamic memory allocation of this structure members. Suppose in earlier example, we have seen that we are storing the details of 5 employees, 6 employees, 10 employees. So what I will do for that problem, I declared an array of size 10, size 20. Fine. So now my question is, can we dynamically allocate that number? Can we dynamically allocate the memory for n number of employees, just like n number of integers, n number of float, n number of character? Can I dynamically allocate the memory for n number of employees? The answer is definitely yes. Just like this, forget about E1, forget about E1. Suppose I want to allocate memory for n employees in this program. Fine. So I have to take help of this alloc-malloc function. So that's why I need to include std lib.h. Very nice. Forget about this pointer for time being. No, I have to declare a pointer variable. So first is int n, why I'm taking this n. That n is basically used to store the number of employees. So first I am taking input from the user, enter the number of employee. Fine. Second, so scanf ampersand, sorry, %d %n. Very nice. So I want to allocate memory for n number of employees, and that I want to do in the runtime. That is by using the concept of dynamic memory allocation. Very good. So after taking input n, what I will do using malloc function, I'm doing this task. So malloc n into size of not integer, not float, not character, size of struct tmp. Because the data type over here is not integer, float, character. The data type is here is struct tmp. And if the memory allocation is successful, then it will return a void pointer And that also need to be typecasted at struct TMP pointer. And I already declared a struct TMP pointer, that is PTR. So I must have to store the address PTR over here. So PTR will behave like an array. So now what I will do, I have to take input for this n number of employees. So I must have to write a for loop for this purpose. So for I equal to 0 to I less than n, I plus plus, and I will take the input for this n number of employees starting from 0 to n minus 1. So that is ID, salary, and name. Very nice. And I want to display, I also want to display the details of those employees. So inside this for loop, I also call the display function. So before that, I need to modify this code because I am using PTR. What is PTR? Try to remember calloc-malloc function. Star PTR plus I is equivalent to PTR of I. I hope you can remember this line. Equivalent to PTR I. Fine. PTR is basically holds the starting address of this successful memory allocation. And there is a if else part. I've omitted this part. I have not mentioned that part over here. That if PTR equal to null, memory allocation failed. Try to remember the dynamic memory allocation part. I'm implementing that part over here. Nothing new over here. So fine. So instead of this E1, what I will write? I may write PTR of I dot ID. That may I write. Or I may write also PTR of I definitely an ampersand is required before that. PTR I is equivalent to star of PTR plus I. Fine. The starting address of that structure variable, not the member. Starting address of that structure variable, not the member. So ampersand of PTR I dot ID, ampersand of PTR I dot salary, and PTR I dot name. I hope you understood. PTR I is equivalent to star of PTR plus I. Mapping it with the pointer variable, just previous program, when I use star PTR. What I have written that time, ampersand PTR dot ID. Okay, let me repeat once again. Just try to map it with the just previous program. In the previous program, what I have declared is a PTR is a pointer variable which is pointing to a particular structure variable, that is E1. So when I'm writing ptr equal to ampersand of e1, actually ptr is storing the address of e1. Now what this ptr doing? Ptr is basically pointing to the address for n elements memory allocation. It's a starting address of n number of memory allocation starting address. So earlier what we know, earlier concept of dynamic memory allocation, we know that star ptr plus I is actually equivalent to ptri. So if I use this ptri, so that means I have to put up before ampersand before that. Why? Because ptri is basically what? It is basically ith index. If you consider that array as ptr, and each and every index I, there is a member, there is a structure variable mp. So definitely I have to put ampersand before that. So in this context, what I have done, I have just given ampersand, I have written ampersand ptri, ampersand ptri dot fal, and in case of name, uh, name is a character array. Name is a character array, so no need to give the ampersand before that, only pass that array name. So that's why you have to write ptri dot name before that. So finally, what I have passed over here, I must have to pass the address of this address of ptri. Right now, the address of ptri, because if we write only ptri, that doesn't mean anything, because ptri is basically pointing to a structure variable. ptri is basically pointing to a structure variable. So then how I will pass this total structure variable, because I'm using here I am using the call by reference for the purpose of display. Fine. So definitely I have to pass the address. Definitely I have to pass the address over here. So how we can pass that address? How we can pass the address? How we can pass the address? The starting address is ptr, right? The starting address is ptr. So if I write ptr of I, that means if I write ptr of I, then I have to give ampersand before that, because ptr of I means actually star of ptr plus I. But if I write only this ptr plus I, this will work fine, because this means the address of the ith index, address of the ith index, address of the ith index. Fine. So let me execute the program, and this equivalent to, if I write this, or I may write this, display ampersand of ptri. This we can write for the same purpose. So either one, both are the correct syntax. So let me execute the program. Number of employees, say I'm giving 3. Enter ID 1, salary 12,000, name A. That's because I have called the display function inside for loop. So after taking input, the output, the display function works. It basically shows the value of those members of structure variable. Second member is 2, salary say 14,000, name is B. Calling display function once again, so that's why it is giving the output. Then ID 3, salary say 15,000, and name is say C. So it also gives the output. Rather, display function is giving us the output. So I hope this much is clear to you. We can allocate memory through this program. What I demonstrate, we can allocate memory for n number of employees using runtime, and we can take the data input. We can take the data input for those employees, and we can use the data in datas for our programming purposes. Here only I displayed that data. It's clear to you? Fine. So what I discussed here, I discussed today about the function which return a structure. Then I discussed the basic pointer concept and how this pointer variable can be used to access the data members for both the time of scanning as well as rather printing the value of those data members. And then after, finally, we discussed today that implementation of dynamic memory allocation in structured programming, where we can want to store n number of structure variables. Rather, we can allocate the memory for n number of structure variables at the runtime. So I hope this much is clear to you. I'm concluding today's session over here. Thank you. Thank you very much.